You think you understand how the world works. You learned it in school, you've seen it in movies, you've heard it repeated so many times that it feels like absolute truth. But here's what's wild. Some of the most fundamental facts that everyone knows, they're actually completely wrong. Not kind of wrong, not slightly inaccurate, completely, fundamentally, scientifically wrong, and yet nearly everyone believes them. Today, we're breaking down 10 scientifically proven facts that almost everyone gets wrong. These aren't obscure pieces of knowledge. These are things you've probably taught to kids, mentioned in conversations, or based your understanding of the world on. Some of these will shock you, others might make you frustrated that you believed them for so long, but all of them will change how you see the world. Let's start with number 10. Number 10, we only use 10% of our brains. This is one of the most famous myths about the human brain. We only use 10% of our brains. Imagine what we could do if we used 100%. Smart people use more of their brain. Movies use this premise. Self-help gurus repeat it. Even some supposedly educated people believe it. Here's the truth. You use virtually 100% of your brain. And almost all of it is active almost all the time. Even when you're sleeping, your brain is working. Different regions activate for different tasks, but there's no part of your brain that just sits idle. Brain imaging studies show this clearly. PET scans and fMRI scans reveal that even during deep sleep, most of your brain is active. It's just active in different patterns than when you're awake. There might be tiny regions that are less active in certain moments, but there's no 90% dead zone sitting in your skull. Your brain makes up about 2% of your body weight, but uses about 20% of your body's energy. If you truly only use 10% of it, you'd be able to function with 50% less brain. You can't. People with significant brain damage, stroke victims, people with tumors, lose serious function. The brain is not oversupplied with redundancy. Nearly every part is essential. So why does this myth persist? Probably because the human brain is so mysterious and powerful that it feels like we're only scratching the surface. People want to believe there's untapped potential. The 10% myth appeals to that desire. But the reality is even more impressive. You're already using your whole brain all the time. The mystery is not about how much you use, it's about understanding how to use it better. Number 9, humans have 5 senses. You learned this in school: sight, hearing, smell, taste, touch. It's simple, it's clean, it's wrong. The myth is so ingrained that it shows up everywhere, in textbooks, in movies, in basic explanations of how humans experience the world. But humans have significantly more than 5 senses. Depending on how you count, we have between 14 and 20 distinct senses. You have equilibrioception, your sense of balance. This is how you know you're upright, how you maintain balance, how you navigate without falling over. This is a separate sense from touch. You have proprioception, your sense of where your body parts are in space without looking. Right now, you know where your hands are without seeing them. You can touch your nose with your eyes closed. That's proprioception. You have nociception, the sense of pain. This isn't just touch that happens to hurt. It's a distinct sensory system with its own receptors and neural pathways. You have thermoception, the sense of temperature. Again, this is separate from touch. You can feel hot and cold as distinct sensory experiences. You have interoception, the sense of what's happening inside your body. Hunger, thirst, your heartbeat, the urge to breathe. These are all distinct senses monitoring your internal state. You have chronoception, your sense of time. Your brain somehow keeps track of how much time has passed. You have kinesthesia, your sense of movement. This works with proprioception to let you know not just where your body parts are, but how they're moving. Beyond these, there are other sensory systems. Baroreception, detecting blood pressure. Chemoreception, detecting chemical changes. Beyond taste and smell. Magnetoreception, detecting magnetic fields, weak in humans but present. So why did we settle on 5? Probably because Aristotle said so around 350 BC, and the idea was so clean and intuitive that it stuck around for 2,400 years. Nobody bothered to update the textbooks even after neuroscience proved it wrong. The truth is far more complex and far more interesting than 5 senses. Your brain is constantly integrating information from over a dozen distinct sensory systems to create your experience of reality. Number 8, you swallow 8 spiders while sleeping every year. This is one of the most widespread myths about spiders. The claim, you swallow approximately 8 spiders every year while you're sleeping. Sometimes the number varies. Some people say 7, some say 12. But the premise is the same. This myth is not just wrong, it's biologically impossible. Here's why. First, spiders actively avoid human mouths. Your mouth is wet, it moves constantly, and it's a dangerous place for a spider. Spiders have no reason to crawl into it. Second, your body has defense mechanisms. If something touches the back of your throat while you're sleeping, you have a gag reflex. You would wake up and cough out anything that entered your mouth. Third, there's zero evidence. Not a single documented case of a spider being found in someone's stomach or discovered during a medical procedure inside someone's mouth. If this happened to millions of people every year, we'd see medical records of it. We don't. The myth likely originated in the 1990s as a thought experiment, a way to test how readily people would believe an absurd claim if it was presented as fact. It worked. The myth spread so effectively that it became common knowledge. People repeated it so much that it became accepted as truth. Spiders are far more afraid of you than you are of them. The idea that they're deliberately crawling into sleeping humans' mouths is not just false. It contradicts basic spider biology and behavior. Yet this myth persists with incredible tenacity, even as it's been debunked hundreds of times. Number 7. Goldfish have 3-second memory. You have the memory of a goldfish is used as an insult to suggest someone forgets things instantly. The claim is that goldfish can only remember things for 3 seconds before completely forgetting them. This is false. Goldfish can actually remember things for months. In studies, researchers have trained goldfish to respond to specific colors or sounds, and the goldfish retain those memories for extended periods. Goldfish can be conditioned. They can learn. They can solve problems. Their memory is not perfect, but neither is yours. So why does this myth exist? Probably because goldfish have small brains and seem simple. People assumed a small brain must mean poor memory. But memory isn't strictly determined by brain size. It's about how the brain is structured and how it processes information. A goldfish might not remember your face day to day, but that's not because their memory is non-existent. It's because they don't have the cognitive framework to care about human faces. The myth persists because it feels intuitively true. Small brain indicates small memory capacity. But biology doesn't work that way. Goldfish are smarter than their reputation suggests, and the myth about their memory says more about human assumptions than it does about fish neurology. Number 6. The great white shark never stops moving. You've heard this. Great white sharks must swim constantly or they'll sink and die. The claim is that because sharks don't have swim bladders, like most fish, they have to be in constant motion or they'll drown. The implication is that sharks never rest, never sleep. They're trapped in eternal motion. It's dramatic, it's compelling, it's also not entirely accurate. While it's true that some sharks need to move to keep water flowing over their gills, great whites actually have a special mechanism that lets them rest. Sharks can go into a state called tonic immobility, a kind of rest state where they're not moving but their bodies are still functioning. Some sharks can even push water over their gills without moving. And here's the thing, not all sharks are like this. Many bottom-dwelling sharks rest on the ocean floor. They don't need to be constantly swimming. Great whites do need to move more than most fish, but they're not trapped in eternal motion any more than you're trapped in eternal wakefulness. The myth probably appeals to us because it creates a sense of tragedy, a powerful creature condemned to never rest. But it's an exaggeration of a biological reality. The truth is simpler. Some shark species need to move more than others, but that's just adaptation to their environment. It's not the curse, the myth suggests. Number 5. Different tongue. Regions. Taste. Different things. Remember that diagram in science class? The tongue map showing that the tip tastes sweet, the back tastes bitter, the sides taste salty. That's taught in schools worldwide as a basic fact about human taste. It's wrong. All regions of your tongue can taste all flavors. You can taste sweet on the back of your tongue. You can taste bitter on the tip. The sensitivity might vary slightly from person to person, but it doesn't follow the old map. This myth originated from a misinterpretation of research from 1942. The original study didn't actually support the idea of distinct taste regions. But the myth was so intuitive, it fit with how people understood language and mapping, that it became accepted as fact. Textbooks started including the tongue map. Teachers taught it, students learned it, it became common knowledge. By the time scientists pointed out that the research didn't support the map, the myth was already embedded in educational systems worldwide. Your taste works through taste receptors that are distributed across your entire tongue and mouth. These receptors can detect all 5 basic tastes: sweet, salty, sour, bitter, and umami. There's no special region for each flavor. The map is completely fictional, yet most people still believe it, and many textbooks still teach it decades after it was disproven. Number 4. Humans evolved from chimpanzees. This might be the most misunderstood scientific fact in the world. People hear humans evolved from chimpanzees and assume it means we descended directly from modern chimps, that our ancestors were chimps and somehow turned into humans. This is completely backwards. Here's what actually happened. Humans and chimpanzees don't share a direct ancestor in the sense of our ancestors were your species. Instead, we share a common ancestor, a species that lived millions of years ago. About 6 to 7 million years ago, this ancestral species split into 2 evolutionary lines. One line eventually led to modern chimpanzees, the other led to humans. We're not descended from chimps, we're cousins. Think of it like a family tree. You and your cousin both descend from your grandparents, but you didn't evolve from your cousin. You evolved alongside your cousin from a common ancestor. The confusion happens because evolution is described in shorthand. Humans evolved from primates. This is true, but people misinterpret it to mean humans evolved from modern primates. What it actually means is humans and modern primates share a common primate ancestor from which we both evolved. We share 98% of our DNA with chimpanzees. This is true, but shared DNA doesn't mean one evolved into the other. It means they evolved from a common source and retained most of the same genetic code. The myth persists because it's constantly misrepresented. People want a simple story. We came from apes. But evolution doesn't work that way. The actual story is more interesting. We're not descended from modern apes. We're kin with modern apes. We share a deep family connection, and we can trace it through genetic evidence and fossil records. Number 3, sugar makes kids. Hyperactive parents have repeated this for generations. If he eats too much sugar, he'll bounce off the walls. That candy is going to make her impossible to control. Sugar makes kids hyper. It's accepted as fact, except it doesn't. Multiple controlled studies have tested this claim. Kids are given sugar or placebo, fake sugar. Their behavior is measured. Activity levels are tracked. The results are consistent. Sugar does not increase hyperactivity in children. So why does it seem like sugar makes kids hyper? Several reasons. First, expectancy effect. Parents expect sugar to make kids hyper, so they watch for signs of hyperactivity. When kids run around, which kids do normally, parents interpret it as sugar-induced. Second, context. Kids eat lots of sugar at parties, holidays, and exciting events. Of course they're excited. They're surrounded by stimulation. It's not the sugar, it's the situation. Third, confirmation bias. Once you believe sugar makes kids hyper, you notice every time a kid eats candy and then runs around. You don't notice all the times a kid eats candy and sits quietly. Pediatricians and nutritionists worldwide confirm sugar itself doesn't cause hyperactivity. What sugar does do, provides quick energy, not hyperactivity, just energy, causes blood sugar spikes and crashes, contributes to tooth decay, leads to metabolic issues over time. But the hyperactivity? That's a myth. Yet millions of parents still believe it and restrict their kids sugar-based on this false belief. Number 2, the left brain versus right brain myth. You've heard this, left brain. People are logical and analytical. Right brain people are creative and emotional. People take brain dominance tests to figure out whether they're left-brained or right-brained. Schools organize teaching methods around this theory. Business gurus use it to explain personality types. It's everywhere. It's also not supported by neuroscience. Here's what's actually true. Yes, the brain has 2 hemispheres. Yes, different regions have some functional specialization. Some language processing happens more in the left hemisphere. Some spatial processing happens more in the right. But the idea that people can be categorized as left brain dominant or right brain dominant, with that determining their personality and abilities, that's not how the brain works. Most cognitive tasks require both hemispheres working together. Creativity requires logic. Logic requires creativity. The 2 hemispheres are constantly communicating through the corpus callosum, the bridge connecting them. People aren't left brain or right brain. People have one brain with 2 hemispheres that work together. The myth probably persisted because it offered a simple way to understand personality differences. It's intuitive, it feels right, but it's not supported by evidence. Brain imaging studies show that people don't actually have a dominant hemisphere that determines their cognitive style. There's no left brain person or right brain person. There are just people with complex brains that work in different ways. Number 1, humans can only concentrate for 8 seconds. This statistic gets cited constantly. Studies show humans can only concentrate for 8 seconds. Our attention spans are shorter than goldfish. We live in an age of distraction where focus is impossible. The number varies. Sometimes it's 6 seconds, sometimes 9, but the general claim is that human attention is extremely limited. This claim is based on a study that never actually found that. The study measured something different, how long someone looks at an advertisement before looking away. That's not the same as concentration capacity. Real concentration is much more complex. You can focus on a book for hours, you can watch a movie for 2 hours, you can engage in a challenging task for extended periods. Your attention isn't fragmented down to 8 seconds. What's actually happening in the modern world is that your attention is being competed for. Your phone buzzes, your email pings, notifications pop up. That fragmentation makes focused attention harder, but your capacity for concentration hasn't changed. It's just being interrupted constantly. When people remove those interruptions, go on a digital detox, work in a quiet environment, turn off notifications, they can concentrate just fine for extended periods. The 8-second attention span is a myth, that serves a narrative. We're broken. Our brains are damaged by technology. Focus is impossible, but that's not what the science shows. The science shows we have normal attention capacity that's being undermined by environmental factors. That's actually good news. It means you can improve your focus by changing your environment, not by accepting that your brain is permanently broken. So we've covered 10 scientifically proven facts that almost everyone gets wrong. We only use 10% of our brains. We use nearly 100%. Humans have 5 senses. We have 14-20. We swallow 8 spiders while sleeping, biologically impossible. Goldfish have 3-second memories. They remember for months. Great white sharks never stop moving. They can rest. Different tongue regions taste different things. Tongue map is false. Humans evolved from chimpanzees. We share a common ancestor but didn't descend from them. Sugar makes kids hyperactive, scientifically disproven. Left brain, right brain. Personality types, not supported by neuroscience. We can only concentrate for 8 seconds, not based on real research. What's remarkable about these myths? They're all facts that people know with absolute certainty. They're taught in schools. They're repeated by authority figures. They're used to explain behavior, justify decisions, and understand the world. Yet when you actually look at the science, they all fall apart. Why does this happen? Several reasons. First, myths are stickier than facts. A memorable story beats actual evidence every time. The 10% brain story is compelling. The reality that you use nearly all your brain is less exciting. Second, we believe what we've been told. If a teacher said it, a parent repeated it, and a textbook confirmed it, it must be true. We don't question it. We just repeat it. Third, the myths are intuitive. They make sense based on how the world seems. Small fish brain, small fish memory feels right. So we believe it without checking. Fourth, myths serve narratives. The 8-second attention span myth serves a story. We're broken by technology. The sugar makes kids hyper myth serves a story. We need to protect children. The myths confirm what we want to believe. The deeper truth, just because something is widely believed doesn't make it true. Just because something has been repeated for generations doesn't make it accurate. Just because something is taught in schools doesn't mean the science supports it. Real understanding requires skepticism. It requires asking, what's the evidence? It requires being willing to change your mind when the evidence contradicts what you believed. Most people aren't willing to do that. Most people cling to myths because they're comfortable. But if you're someone who wants to actually understand how the world works, not how it seems to work, then you need to be willing to question everything you've been told, including the things that are so obvious you've never thought to question them. The scientific method is not perfect. Scientists disagree about many things, but it's the most reliable tool we have for separating fact from fiction. When there's a gap between what everyone says is true and what the research actually shows, the research is worth paying attention to, because the world is far more interesting than the myths we tell about it. Thanks for watching. If this challenged any beliefs you've held your whole life, like this video, subscribe for more science-backed insights that contradict conventional wisdom, and drop a comment telling me, which of these facts surprised you the most? And what's something you thought was scientifically proven, but now you're questioning?